This is section 11.3, areas of polygons. The first thing I want to start off with is talking about the area of a rhombus or kite. When doing this area, all I am doing is taking the diagonal 1 times the diagonal 2 and multiplying that by 1/2. If you notice, I have created with my diagonals different triangles. And so what I'm doing essentially is the height, or I'm rather doing the base times the height of two triangles and then multiplying that by 1/2, just like I would a triangle. So, like I said, area equals 1/2 base or diagonal 1 times diagonal 2. So I'm going to go ahead and do that on two examples here. So this first example, one thing that you need to know about the diagonals is they are interchangeable. It does not matter which diagonal you use as diagonal 1 or diagonal 2. So my area is going to equal 1/2 diagonal 1, diagonal 2. So I'm going to have 1/2 of 6 times 8. 1/2 of 6 times 8 is 1/2 of 48, which gives me as the area 24 meters squared. Now moving on to this next one, I'm going to have the area of 1/2 of diagonal 1 times diagonal 2. That gives me 1/2 of 7 times 10, which is 1/2 of 70. So my area is going to equal 35 centimeters squared. And that's doing rhombus and kites. So the next part I want to step into is actually talking about regular polygons. Regular polygons are anything greater than what we already know. For example, it would be a pentagon and higher. The reason we have a separate formula for this is because we can't do length times width or base times height. It's got a bunch of different parts to it. So we have to use something called the apothem. The apothem is the distance from the center to any side of a regular polygon. What is important to remember that if you are not given the apothem, you have to find it first. So my formula looks like this. I say the area of a polygon equals the area of one triangle times the number of triangles. That can be broken down into the following formulas. I'm doing 1/2 times the side length times the apothem, which would be the height of the triangle, times the number of sides. If I reduce that and change where my parentheses are, this would be, oh goodness, I can't even remember the property name from elementary school, or middle school even. But I'm switching where my parentheses are. This is a special property that says I can do that. And it's 1/2 times the apothem times the number of sides times, it's the number of sides times the side length. This also equals my perimeter. So I'm going to use this lovely formula. I'm going to figure out what 1/2 times the apothem times the perimeter is. And that'll be the perimeter of the entire polygon. So the area of a regular n-gon with side lengths S is 1/2 the product of the apothem and the perimeter. So let's go ahead and do an example of this. So I chose an example that you would have to find the apothem in, and I'll talk about how we do that. So I have a regular nonagon. That's the important thing to remember. I have 9 sides. A nonagon is 9 sides. Inscribed in a circle with a radius of 4 units. I have a radius. That's not the apothem. We need to find the area of this nonagon. So I'm going to go ahead and zoom in here so we can look at the triangle. And what I'm actually going to do is I'm going to redraw the triangle off to the side so that we can have a specific picture of this triangle. And in this triangle, we are told that that line here in the middle of it is perpendicular. This is my apothem. So if this is my apothem, we're going to label this as A. We also know that this is 4 and this is 4. I have L, I have J, I have M, and I have K. So we need to find my side lengths, which is going to be this entire thing is a side length. To find that, I first have to be able to find what this is. Just that part of my side length. I cannot find the entire thing if I don't even have part of it. So the first step I need to do in this type of problem is I need to actually find my side lengths. Let's start with my apothem. If I want to find my apothem, I have set up here a right triangle. Now it's not a special right triangle because a nonagon, when you determine the interior angles of that nonagon, it is not going to equal 30 or 60 or 45. So what I first have to do is I have 9 sides. If I have a circle of 360, I'm going to divide that by 9 to figure out what all of my central angles would be. These are all congruent central angles. And that gives me a total of 40. So I already know that the entire angle L is 40. So if I want to figure out this little sliver, it's going to be 20 degrees because I'm wanting to cut 40 in half. So that's the first step here. The second step to this is I need to solve for the sides. To do that, I'm going to have to use my trig functions from chapter 9. So we're going to start with the apothem. Starting with this is my reference angle, the 20 degrees as my reference angle. My apothem is going to be adjacent, and my 4 is going to be my hypotenuse, making my y my opposite. So I'm going to start with that. If it's adjacent, I'm going to use cosine. So I'm going to do cosine of 20 degrees is going to equal adjacent, which is A, over hypotenuse, which is 4. I'm going to multiply both sides by 4 to get rid of that off the bottom. And I'm going to have A equals 4 cosine of 20 degrees. That gives me, or we're going to leave it just as that for now, until the very end is when we're going to round. The next thing I have to do is I have to do sine of 20 degrees to get y. That's going to give me y over 4. Again, I'm going to multiply both sides by 4 to get rid of that off the bottom. And I'm going to have my y equal 4 sine of 20 degrees. Now that doesn't give me my side length. The next step here I have to do to find my side length is I need to multiply it by 2. because as I showed in my picture, my y is going to be half my side length. So I'm going to end up with 8 sine of 20 degrees. So now I'm going to plug everything in to my area formula. My area formula says that I'm 1/2 times the apothem times the perimeter. My perimeter is going to equal side length times the number of sides. So I'm going to have 1/2 times the apothem, which we said was 4 cosine of 20 degrees, times my side length, which we said was 8 sine of 20 degrees, times the number of sides that I have. In this case, it's a nonagon, so 9. From here, I'm just going to type this all into my calculator, making sure I use the proper parentheses and all of that. And I'm going to get about 46.3 units squared. Since I don't have a unit of measurement, I have to put the term units. This is an example of the work you would have to do if you had to find the apothem. Now, if you already have the apothem, and you already know what the number of sides are, you already know the side length, all of that, then all you have to do is just plug it into your formula. Now, you may have to find the side length. Again, that is used by using your trig functions, or possibly Pythagorean theorem, if you have the apothem. Looking at those problems, you just have to determine which one will work the best.